Our next presenter is Agnese Marchini from, I hope I got that relatively correct, from Universita di Pavia, Italy, and Agnese is going to speak to us about fouling on recreational boats as a major spreading vector. Thank you.
Thank you everyone for listening, and John for inviting me. I am very pleased to narrate you what's happening in the Mediterranean Sea. The Mediterranean is a relatively small sea. The surface is 2.5 million square kilometers. So it's 1/3 the surface of Australia. Yet the coastlines are bordered by 23 countries, including 8 member states of the European Union, plus 3 European countries that are not in the EU, plus Asian countries and North African countries. And of course, it has a long history and a lot of cultures and a lot of non-indigenous species. We are not proud to be the world champions of alien species with about 800 multicellular NIS. All the unicellulars in the Mediterranean are considered cryptogenic, so this only includes multicellular taxa. As you can see, the phenomenon has not been stopped. There is basically no vector managed, and especially the largest vectors are not managed, which is the Suez Canal. So we have a problem. So the regulatory framework that we have in the Mediterranean is set by the Barcelona Convention, which is a regional sea convention where the Mediterranean countries are contracting parties. In 2005, a regional action plan on introduced and invasive marine species was released, and at that time it promoted the development of regional action plans on ballast water and biofouling. The regional action plan of ballast water was eventually done, but on biofouling there were no activities. Then the action plan was updated in 2017, and still, as you can see, there is a promotion of the development of national action plans of dealing with all vectors, including fouling, but at the moment nothing has happened. Then another regulatory framework that we have to take into account comes from the European Union. We have in 2008 Marine Strategy Framework Directive from the European Community, which includes non-indigenous species as one of the descriptors of good environmental status. So member states have to measure non-indigenous species now to measure the good environmental status. And this promotes monitoring of hotspots area. And then in 2014, we have this revolutionary regulation of the European Union on invasive alien species. But at the moment, it does not affect any biofouling species. Most species in the Union list of species of concern are terrestrial plants. Mainly, there is only a very few marine species and no biofouling species, but this list is constantly being updated, so it's possible that in the future we will have fouling species in the list of European concern, and we will have then to activate prevention and management measures, which we are not ready for, because the reality is that monitoring has really just been started about 1-2 years ago, and it's very confused to understand what countries are doing, and even I don't understand what's going on in my own country, because each region is doing different stuff. There is no biofouling prevention activity and no control activity. So this presentation will not show you innovative solutions, but it's more an assessment that we tried to do of what the fouling problem is in the Mediterranean Sea, and we especially targeted recreational boats, which is a big thing in the Mediterranean. There is about 1.5 million boats, which represents 20% of the whole global boating. So 1 out of 5 boats in the world is in the Mediterranean Sea. Of course, it is a boating paradise for the pleasant weather, the diversity of geological and cultural landscapes, and we have also a lot of facilities, of shipyards, boatyards with hull fouling cleaning facilities, and also we are world leaders for the production of super yachts. So there is a huge culture of recreational boating in the Mediterranean Sea. So our work was trying to understand how it affects the introduction and spread of non-indigenous species. So we try to understand what recreational marinas host, what are the factors that promote richness of non-indigenous species in marinas, and what's under the boats. So we try to explore the hulls of the recreational boats in the Mediterranean Sea, and also to explore the level of awareness of boaters, Mediterranean boaters. So we did inspections of marinas using mainly scrapes, but that it was the fastest and cheapest method that we could use. We also surveyed boats by dive, snorkel, or whenever possible at the boat yards when they were hauled out for maintenance purposes. Submitted questionnaires to the boaters regarding their travel history, their boating maintenance practices, and their awareness on the non-indigenous species problem. And also did a huge work of identifying all these taxa that we collected in both in the marinas and boats, focusing on the macroinvertebrate fauna. We also tried to collect information on factors in the marinas that can promote non-indigenous species settlement. Unfortunately, it was hard to have the collaboration of marina managers in many instances, so we could not collect whatever we wanted to. So we used these factors that we have listed here. So some environmental factors, some features of the marina, and also we measured proximity to other possible vectors of introduction, namely aquaculture, shellfish farms, ports, commercial ports, or proximity to the Suez Canal. Our study area encompasses 7 countries, from Spain to Turkey, and we managed to collect data from 50 marinas. And this was not a large funded project, but this is the efforts of just 2 PhD researchers that are the 2 amazing girls that are in the photo with me, Jasmine and Eileen. In particular, we did different steps. In the first steps, we wanted to test for difference in NIS richness between commercial harbors and neighboring marinas, and this was focused on the northwestern Mediterranean in Italy mainly, and in 5 sites. Then we did this large putting together of data to test for the abiotic factors that promote NIS richness. So we had the whole data set of 50 marinas. And the boat hull study was limited to 25 out of these 50 marinas because it was the sites where we were able to do boat surveys. Not everywhere it was allowed or it was possible. And we managed to collect data from about 600 boats. So the first part of the study was to compare NIS imports and neighboring marinas. And this was the first surprise we had, that if we compare richness of non-indigenous species and the ratio of NIS over natives, you see that there, in some cases, there is not a significant difference. So we always considered harbors, commercial harbors are as hotspots, but we then understood that marinas can be hotspots as well. And the composition of species in marinas was not a subset of the composition in harbors as we expected, but it was different, was unique, and we also found new species for the Mediterranean in the marinas, not in the harbors. So that was a first hint that marinas could be important, and the results of this were published on the journal Biofouling in 2017. Then we did this large study on 50 marinas, and we identified 74 non-indigenous species, ranging from 2 to 27. Our champion was Heraklion in the Crete island in Greece. And as you can see, most marinas have from 10 to 20 NIS. There were also a lot of new records for country and for the entire Mediterranean Sea, so we published everything in one big paper because there was a lot of new information coming out from this Marina Survey. Some species had a more regional or local distribution, maybe the newly arrived, but there are many NIS that are very widespread in the Mediterranean Sea, and so the pattern of NIS composition is very homogenized, meaning that there are many connections between the Mediterranean marinas. So we have species that occur in more than 50% of the sampled marinas. Then the factors that we have tested and found significant for significant relation with NIS richness were both continuous and like quantitative factors and qualitative categorical factors. And in particular, those resulting significant were temperature, number of birds, proximity with Suez Canal, and to aquaculture site, commercial harbors, then the presence of pontoons, and the geographic sector of the Mediterranean where the marina is located. So this is a correlative study. We cannot drive too many conclusions from it, but it's already an indication to what can be a high-risk marina. So these results have been published this year on the Journal of Environmental Management. And then we addressed the boats, about 600 boats, I remind you. And out of this, very few have no fouling or clean. And the majority, meaning over 70%, have at least one NIS. This is a lot. This was a huge surprise for us, and we found up to 11 NIS in a single boat hull. We also found that this richness is often correlated to the richness in the marina where the boat is berthed most of the time. This is pretty obvious. Surprisingly, NIS occur also on very, very recently cleaned boat hulls. This is just a selection of a list which is longer. So we have cases of boats cleaned 1-2 weeks ago. Some in water cleaning, you have IW, and somewhat dry cleaning with D, still you see non-indigenous species on the hull. So it's clear that the common cleaning procedures are not working, cannot help in stopping the spread of the species. And we also collected and used the data from the interviews of the boaters to try to relate the NIS richness on the hull to the boating maintenance of the owner, and found these factors to be significantly correlated with NIS richness. These are all pretty obvious, like time since last clean, time since last paint, number of days spent traveling, and boat length and average cruising speed were negatively related to NIS richness. Another interesting aspect is that Mediterranean boaters are pretty active. You see this map is hand-drawn from the data we collected from our interviews. Unfortunately, we were not able to collect data from the marina managers. They were not willing to share with us their traffic data, privacy or whatever. So this is from our own interviews, and that is why the southern part is not covered, because we did not sample there. But you see that it's interesting that boats come and go from all possible entrances, including waterways in France, then the Gibraltar Strait, the Dardanelles Strait towards the Black Sea, and the Suez Canal. We finally have the proof that recreational boat, because this was a quite confused information, but we managed to interview boaters that go to Seychelles or Madagascar through the Suez Canal. So it's also a vector. And they spend, on average per year, 76 days outside their own marinas and visit, on average, 7.5 new marinas per year. So it's a lot of movements and a lot of non-indigenous species being moved. These results have been just recently published last week on the Journal of Applied Ecology. So, first challenge we have to face is awareness, because unfortunately, we could estimate that awareness is generally poor. When we interviewed boaters about what are the alien species you know, so in the Western Mediterranean, most boaters reply the Caulerpa taxifolia, the killer algae, because they had a huge invasion, but that was caused by another vector, an aquarium spill. And in the Eastern Mediterranean, they name rabbitfish, lionfish, or pufferfish that are Suez Canal immigrants, so not related with biofouling. They don't name any biofouling species. Then they name a lot of weird species like the sunfish, the monk seal, which is endemic endangered species, or squirrels, or turtles, or many, many different things. So level of awareness is something we really have to work on very intensively. And then we have to learn how to do monitoring, because especially non-European countries are behind. We lack taxonomic expertise and protocols, standard protocols to apply. And this is all to be built. So there is a lot of work. It's a good news. There's a lot of work to do. And okay, so a little initiative that just happened last week. We organized first international summer school on biofouling monitoring. We invited teachers from the Smithsonian Environmental Research Institute, from the Greg Ruiz lab, to teach their protocol, and we were very happy. It was in my university, and I was very happy to host participants from Egypt, Tunisia, and Israel, along with participants from European member states. So this is just a little initiative that we hope we can continue to start spreading some standardized methods. Okay, that's it. I gratefully thank my co-authors, especially Jasmine and Eileen, that are the two PhD students that worked on this. And thank you very much.